So for our first question, in 1993, Forbes magazine reported the age and salary of the chief executive officers of each of the top 59 small businesses. Here was the salary data rounded to the nearest $1,000. So it gives that data, and what we can do is we can plug it into the calculator under list if we would like, and it shows the distribution of it. And also we can sort the data in groups of 200. So you go from 0 to 199, 200 to 399, 400 to 599, 600 to 799, 800 to 999, and 1,000 to 1199. And then you count the numbers that fall into each category, and that would be the frequency. So for the first you have 6, and then the largest is 32, and then 10, and then 6, and then 4, and then 1. And then using this frequency that we found, we can construct a histogram by putting the frequency on the y-axis and the salary on the x-axis. And we just put the groups for each one. And I did the scale on there by just by 2. And so the top one is here at 32 and the lowest one is here at 1. And this just shows that the data is skewed right. It shows that the highest frequency rests in 200 to 399, which that means that is like the center. There are no apparent outliers and there's no gaps in the data. The median salary is $350,000 and the minimum is $21,000. The first quartile is $250,000 and the third is $543,000. The maximum value is over $1 million at $1,103,000. This shows that the spread is a very large range, but at the same time we can break it up into smaller categories and see that most of the data falls within these 3 areas. For question 2, in 1864, a published paper provided chest measurements in inches of 5,738 Scottish militiamen. The table summarizes the data below. So this already did the first step of the last problem for us, and it goes ahead and gives us the frequency of each chest size. But now we have to sort them into groups because we can't have like this many values. So for this question, I sorted it by 3s and did the first one 31 to 34, 35 to 38, 39 to 42, 43 to 46, and 47 to 50. And the frequencies were really large numbers for the middle 3, but it goes from 21 to 1445 to 3744 to 512 to 26. So there's a very big scale on our y-axis for this histogram. So I counted it in 200s because that was the best way to get up to around 3,800 and also still be able to show 20s. And then I put the 5 categories at the bottom on the x-axis. And this is approximately normal because it follows the standard curve. The median is 40.5 inches, so it would fall into this category right here. The spread from the minimum, the spread is from the minimum of 33 and the maximum of 48, and there are no noticeable gaps or outliers, and this data may have been useful in determining uniform sizes because there's a lot of men, and that way they would know how many they need for each size. Question 3 says, as part of the United States Department of Agriculture's super dump cleanup efforts in the early 1990s, various sites in the country were targeted for cleanup. 3 of the targeted sites, River X, River Y, and River Z, had become contaminated with pesticides because they were located near abandoned pesticide dump sites. Measurements of the concentration of aldrin, a commonly used pesticide, were taken at 20 randomly selected locations in each river near the dump sites. The box plots shown below show the 5-number summaries for the concentrations in parts per million of aldrin for the 20 locations that were sampled in each of the 3 rivers. So here they have already constructed the box plot for us, and we can see that there is River X, River Y, and River Z. So the first question is asking us to compare the distributions of the concentration among the three rivers. And for that, we can see that River X has the widest spread with the minimum at 3.4 and the maximum at 8.7. River Z has the smallest spread with the minimum of 3 and a maximum of 5.1. This means that River X's concentrations of aldrin varied a lot and that River Y's varied less and River Z's concentrations varied the least. The median for all three rivers is around 4.2 to 5.1. There are no apparent outliers or gaps in any of the river data sets. River X has received most of the pesticides, as seen in this box plot. And then for question 2, it gives us the 20 concentrations of River X. So I plotted them into a stem plot as it asked me to do. So I put the first number on the left as the stem, and then whatever decimal followed as the thing that stems off of it. So we can see that there is a gap in the data because there are none in the 6 category. And the data is skewed right because most of the values are up here and there are less ones down here. And it was not as noticeable from the box plots because there was a lot more like data being accounted for besides just the one river. But when broken down and you can see the actual values, you can understand the difference between them all. So stem plots help to make more accurate assumptions about the data as opposed to just approximating with box plots.